Hello everyone, this is Dr. Oz. In this video, I would like to use a spreadsheet, or in other words called what if spreadsheet, to show you solver how to solve this problem. Okay, to do that, I would like to quickly create my Excel file. So let's create a new Excel file. Right click, new Excel. All right. And I would like to name this one as a par example. So I'll call it linear optimization problem, which is gonna be a par. All right, that's the example. Double click on that Excel file to open it up. All right, so now in this Excel file, I would like to build my model. I like to organize my given information on the left-hand side, and I like to color it. You can choose whatever color you want. I just like to have giving some colors to my Excel file, which makes it readable for me. So I just like red here, and then Control B will make it bold, or you can just click on the B here to make it something bold in Excel. If you double click on the column, it will adjust the length, or same thing rows of that column or row. I would like to enter my given information here. Okay, so I have in this case 4 different departments as we talked about. The first one is the cutting. Zoom in for you guys a little bit. Cutting department, right? Cutting and dyeing. I have sewing department. I have finishing department, and also I have inspection and packaging department. And also in this problem, I have given profit per week. So in this given part, I like to enter everything that's given to me in the problem. So this is a great idea to, I think, build models. So I know what I know and I know what I don't know. So that's a great thing to start with. So I have standard products, standard bags, and I have deluxe bags, right? So if you want to center something in Excel, you can highlight it and then click on center, right? If you want to make it bold again, you can click on B here, or you can Control B, and that will bold it as well. So these are given us to be production time. So let me just write production time. And I like to put everything in units because I don't want to forget what I'm talking about. So these are hours, okay? So if you want to merge multiple cells, you highlight them and click merge and center. Again, Control B to make it bold. So here I have, it will take me, it's given that it will take me, let me just go back to our presentation to get that input ready for us. So let's go back to what's given to us in our problem. So, okay, 7/10 of an hour, right? 7/10 of an hour. So I'm gonna enter that here is equal to 7/10. Enter, and then sewing department is 1/2 is equal to 1/2, and here I have 1, and inspection I have 1/10. Okay, perfect. And for deluxe department, we have a not product, 1 hour of cutting and dyeing department hours is needed per product. And here 5/6 hours, which is like 50 minutes. And here I have 2/3, and then 1/4. Right, so these are hours required. So if I highlight them, click on the number, that will give me number format, which is 2 digits and the number itself. You can play with those number of digits by clicking on these arrows, okay? All right, so now next thing is given to me in this problem was available hours, number of hours available to me. So I will enter that in Excel. So basically, I'm entering everything that's given to me directly to Excel. So for me, I have time available in terms of, again, hours. All right, I'm gonna center this too, and Control B. Again, this is not fitting here. All you need to do is double click. Perfect. So I have 630 Rs available in the cutting department. Assuming I have 600 Rs and 708 Rs here, and I have 135 Rs here. Perfect. So now I can enter my profit per bag. These are dollars. $10 and $9 for deluxe. So I will make them dollar by highlighting them and clicking dollar sign. Perfect. Now I would like to build my model in this section. Again, it's so important to organize these Excel files because you are going to share this file with someone else in your company. You want to make sure they understand what's going on. All right. So this is going to be my model. So again, in an optimization model, we have three components. One is the objective function. In this case, the objective is maximize the profit. All right, so, and we know how to calculate profit, right? In this case, coefficients times the decision variables. And the coefficients are basically $10 times number of standard products produced plus $9 times number of deluxe products produced, right? So that's my objective function. All right, so I will make that calculation right here. So I like to use green color for objective function. You can choose whatever you want. It just helps me to standardize the process a little bit. And the second component, as I told you, is decision variables. We need to define what I'm trying to decide in this model. So I have two different decisions here. One is bags produced for standard products and deluxe. All right, and deluxe. All right, so these are my decision variables. All right, and I have no idea about these values, so I will highlight yellow, but I have no idea about these. So Excel Solver will calculate these values for me. So let's go to the constraints. So I have, again, 4 different departments. And as I told you, constraints have their left-hand side values relationship to their right-hand side values. Again, right-hand side is given, left-hand side should be calculated, all right? So here I have, again, I will copy paste these 4 departments. All right, so availability constraints, right? In the model section, I don't like to type anything. I like to reference everything. So if I change anything in a given section, my model should be updated automatically. So my right-hand side value for cutting is here, 630 Rs, enter. And I can just drag this one down instead of just referencing them one by one. As you see, they are all referenced correctly right now. And as we talked about, these are less than or equal to, because I have 630 Rs available, I cannot exceed that. So click on that. Right down corner, when you see black cross, you can drag it down. So these are the relationships. Again, this is given. These are relationships that you need to decide. And now I need to calculate my left-hand side values. And again, these values should be calculated. Again, this right-hand side is given. This should be calculated. So how am I going to calculate it? It should be calculated based on the coefficients, because it's a linear function, and the decision variables. So what are the coefficients for cutting department? Okay, I need 7.7 hours for standard product, but I don't produce only one. How many do I produce? I don't know yet, but that number will be calculated here by Excel Solver. So I just reference there. Plus, how many deluxe I'm producing? I don't know. What's the coefficient? $1 hour per product. So if I produce 10 deluxe, it will cost me 10 hours. If I produce 100 deluxe, it's going to cost me 100 hours. So coefficient times the number of deluxe produced. So I don't know yet, but Excel Solver will recalculate it for me. So I'm a lazy guy, and I think it's a great idea to be lazy in this case, to be efficient. I don't want to type these formulas for every single one, so I'm going to drag it down. So I need to decide what to lock in. So do I need to lock in the C4? No, because when I drag this one down, I want this blue cell to go down as well. Do I need to lock in D4? No, I want this one to follow me when I drag this one down. All right, how about H6, which is right here, decision variable? Of course, I need to lock it because when I drag this formula down, I don't want this cell, red cell, to go down. So to do that, I press F4. Again, for Apple, I think it's Apple 4. So you just need to make sure that Apple shortcuts are a little different. Basically, to put a $sign in front of the letter and number, that means that this cell is locked in. Same thing with this cell. So I want to lock in that one too, F4, enter. So now when I drag it down, basically my formulas are perfectly right. My coefficients are here, my variables are here. And also, as we talked about, there is a non-negativity constraint that I need to consider. So now I emphasize on my constraints. They are done. So what I would like to do is now I would like to write my objective function in terms of my decision variables as well. So what's my coefficient? $10. I'm not typing 10. I need to reference the given information because they may change in the future. Times my S, which is decision variable right here. I will get the value later. Plus 9, which is right here, profit margin, times deluxe production amount right here. Enter. So my objective is set based on decision variables, right? Based on decision variables. My constraints are set based on decision variables. So now next step, I can solve this problem. What do I need to do? I need to go data and solver. There is a high chance that this solver doesn't appear here by default. So if this is the first time you are using solver, you need to go to file, options, if I can find it somewhere here, right here. And then here you will see, okay, so I think I'm in the wrong, no, not the wrong place, right here, add-ins. Once you click on add-ins, you will see here solver add-in, you see, solver add-in, or you can see analysis tool pack. That should work too. Then you will see Excel add-ins here, and then click go. And then make sure that the solver add-in is checked. So if I uncheck it, you will see that that solver will disappear under data. There is no solver anymore. So if I want to edit for you guys again, one more time, file, options, add-ins, analysis tool pack, go, make sure solver add-in is checked, and then click OK. Now that will add the solver under data tab. Take some time. There you go. So now I can click on solver. Now rest is pretty simple. All I'm gonna do is keep the reference those Excel functions into my solver. So first thing Excel asks me is set objective. What's my objective? This green cell. Click on that, enter. Is it a maximization problem or minimization problem? I'm trying to maximize the profit, so I'll maximize. What are my variables or decision variables specifically? These yellow cells, I will highlight those too, okay? Now I need to add my constraints. So you can add the constraints one by one. However, since these constraints have the same relationships, I can add them in one step. Click add. Excel is asking first left-hand side values. Highlight these left-hand side, 4 left-hand side values. Choose the relationships, less than or equal to. And then click here, choose your right-hand side values right here. And then click OK. And you will see here one set of constraint that includes 4 constraints. Then Excel is asking you, hey, can they get negative values? No. So that's why make sure this is checked. Make unconstrained variables non-negative. That means that my decision variables cannot be negative. This is good. So now I need to choose what kind of model am I dealing with. As I told you, this is a linear program, LP, and we are using simplex algorithm. LPs are significantly easier than solving integer, non-integer programs that we will cover later on in this class, all right? Simplex LP. And then I click solve. Now, once you click on that, you will get your solution. It says all constraints and optimality conditions are satisfied. Yay, I got my solution. So you could just click here to get your sensitivity analysis report and click OK. That will create another report I will cover next presentation. So as you see, my best solution here is I can make $7,668. That's the highest you can achieve. If you can get something better than this, just send an email to Microsoft because their solver is wrong. But believe me, this is a very solid program. So this should be the maximum profit you can handle, you can get. And I need to produce 540 standard units, and I need to produce 252 deluxe. So I want to make sure that all my constraints are satisfied, which Excel said yes, but I want to see visually. I had 630 hours available to me in cutting department. I used it all. I had 600 hours available to me here sewing. I used not all of it, but less than or equal to, that's good, 480. I use all my finishing hours, and I have some slack in inspection, but still it's under 17, is less than or equal to 135. So there is no violation. Non-negativity constraints, as you see, my decision variables are positive values. So they are not negative. So that's satisfied as well. So that's it for this video. I will see you in the next video, and enjoy optimization. Bye.